Are there any known examples of human DNA that has been permanently modified by a past virus? Is there any indication that our modern human DNA has been modified by past viruses to become what it is today? Yes. It's actually thought that without the infection of a retrovirus on one of our ancestors, mammals wouldn't be mammals. A retrovirus likely paved the way for the development of the mammalian placenta. Extra reading: https://www.pbs.org/nova/article/endogenous-retroviruses/. Why does U-235 split when hit with a neutron instead of becoming U-236? Interestingly, it does become U-236 just before it undergoes fission, but the amount of time that it's U-236 is fractions of a second. What happens is that the U-236 nucleus that's briefly formed has a lot more energy than U-236 wants to have, so usually the U-236 nucleus splits into two smaller nuclei, 1/3 and 2/3 the mass, and a few extra neutrons. It can stay as U-236 and give off a gamma ray to release the energy, but that's a lot less common than fission. Is there a point in space where if you look at one half of the night sky you would see the light from stars and the other half would be darkness because there are no stars beyond you in the universe? We do not know. From Earth, we can only see the light from stars that are close enough that their light has reached Earth, aka observable universe. We can't see anything beyond that because, if there are stars beyond that distance, their light has not reached Earth. How are the Nazca lines so permanent? After hearing about this hilariously amateur https://www.bbc.com/news/world-latin-america-54593295 looking newly discovered Nazca drawing, I again began considering the Nazca lines as a whole. How are they so lasting? I read that all they are is displaced or depressed dirt, with a layer of differently colored soil filled into the space. How has this not been washed away, or how has the surrounding soil not eroded to the point of them not being noticeable? No plants have grown in them. Other soil hasn't filled them in. I get that that's part of why they're such a wonder, but I'm wondering if anyone can shed some light on just how they've lasted thousands of years. If you think that's weird, check out Peru's candelabra. In roughly 200 BC someone carved out the beach sand in the shape of a candelabra, and the complete lack of erosion means that's it's still there today. https://en.wikipedia.org/wiki/paracas_candelabra https://en.wikipedia.org/wiki/paracas_candelabra. Why don't substances like hydrogen occasionally combust at low temperatures due to the long tail of fast-moving molecules? If hydrogen starts to combust immediately at 900 K, why doesn't it eventually start to combust at lower temperatures, say 300 K? Is it just incredibly unlikely that any molecule would be moving fast enough, or is there some other factor that determines when molecules react other than the kinetic energy with which they approach each other? Chemical reactions have a minimum activation energy, i.e. the energy needed to result in a reaction. You may or may not have molecules which reach the kinetic energy required, but it quickly gets redistributed. It's not a case where one molecule reaches the required energy and triggers a chain reaction. You need an appreciable number of molecules with energies equal to or higher than the activation energy for the reaction to occur. Why aren't bacterial pandemics as common as viral epidemics? It seems as though any modern epidemics or pandemics with importance are caused by viruses like the swine flu, the Spanish flu, HIV, AIDS, COVID, but the only bacterial epidemic I can think of is the bubonic plague. Is there any reason for the lack of bacterial pandemics, or am I just forgetting some that have occurred? Why do antibodies for diseases like chickenpox stay in your body for years, while they only last a few months for other diseases? There are white blood cells in your body that have memory, like a seasoned vet from a war. Some are hyper-alert for signs of infection. Others pump out antibodies instead. Over time these seasoned vets die and their memory fades. This happens with the tetanus vaccine, and is why you need boosters. Chickenpox is a tricksy one because the virus, Varicella zoster, hides in your nerves after the first infection. Because it never really goes, the body's immune memory never fades. If healthy, those seasoned vets keep the chickenpox virus suppressed. This is also why you sometimes get shingles when you're tired or sick, because the infection comes back out of the nerves. Some viruses like measles wipe out your seasoned vets early, making you vulnerable to previously encountered illnesses. This is one of the reasons it can be so deadly, and vaccination against it is absolutely essential. Is inbreeding not an issue for insects? It seems like very, very few insects can result in an explosive infestation: roaches, ants, bed bugs, etc. Do insects not have the same negative effects from inbreeding that other animals do? The answer to your question is more of an effect of the vast number of offspring a typical insect is capable of producing. Take a human couple and put them in an ideal situation. They procreate and produce an offspring in the first year. Now take two insects and give them ideal circumstances. In the first year they produce several hundred offspring. From that you can figure out how long will it take the humans to fill their environment, versus how long it will take the insects. In biology this is called R&K selection. R selection is producing lots of offspring and hoping that some of them make it. K selection is producing a few offspring and investing lots of time and energy into taking care of them. Both R and K have their pros and cons. How do the Voyager probes measure the particle density of space? I ran across this PopSci article, https://www.sciencealert.com/for-some-reason-the-density of-space- is higher-just-the-solar-system which says that both Voyager probes have detected slight increases in particle density of space after leaving the heliopause. Assuming that's actually correct, I'm curious what instruments are used to take these measurements, and how those sensors work. It sounds awfully impressive to have the level of sensitivity described for machines as old and surely weathered as the probes are by now. Are vaccines owned by companies? Can anyone access the how-to and produce a vaccine in a lab? Thank you. It depends on the vaccine. Generally, pharma companies take out a patent on their drugs, including vaccines. The patent grants them the exclusive right to manufacture it for 20 years, at least in the US. The patent includes all the detailed information about the drug, including its chemical composition. As a result, how it's made is no secret, but it's illegal to do so without the patent holder's permission. Generics are typically just drugs whose patents have expired and are able to be made by any company, usually with a small inconsequential variation. This drives prices down for the drug across the board. Do wild animals change their behavior after near-death experiences? Everyone has probably witnessed a scene in a nature documentary or otherwise where a prey animal miraculously escapes the jaws of its predator. Sometimes, the animal even appears to have come to terms with its fate and succumbed, only to be given a second chance. I have always wondered, does the survivor change their behavior to avoid the situation that almost led to its death? Does it think twice before visiting that watering hole again? Does it look over its shoulder a little more frequently? Is what we refer to as survival instinct just hereditary paranoia from ancestors that almost died? https://www.newscientist.com/article/dn13412-butterflies-remember-caterpillar-experiences/if an insect changes its behavior and can maintain that memory while morphing from a caterpillar to a pupa, its guts melt into goo and reconstruct, and finally into a butterfly, then of course animals can do the same.